about the liquid hydrogen applications. So now we move on to next topic, to our next speakers. Unfortunately, Peter Thompson is unable to come today because of his urgent appointments. However, he invited his colleague, Mr. Jeremy Fouillou. Is it? Fouillou. Is it? How to pronounce it? Fouillou. Is it a French name? Yeah. To come over to give us a talk in the areas of the hydrogen developments for buildings. We are very grateful. Germany will, on behalf of ARUP, to deliver the talk. He's one of the senior management personnel in ARUP, and he specializes in applications of hydrogens for buildings. So, ladies and gentlemen, please welcome our next speaker, Jeremy Fouillou, to come over to the stage. Thank you.
All right, perfect, thank you. Hi everyone, so just filling in for Peter Thompson today. I'm here to present a short internal study that we did at ARUP. And the reason behind this study is that many of our clients in Hong Kong happen to be actually property developers and building operators. And in conversation with them, we started discussing the potential of using hydrogen fuel cells for stationary power generation and decoupling their power and carbon emissions from the grid, mainly CLP and HK systems. So a very quick introduction to ARUP firsthand. We are a multidisciplinary company. We span all 5 continents. Although we started in structural engineering, we're now involved in building projects, infrastructure projects, and myself in energy advisory projects, mainly around East Asia from our Hong Kong office. We've been involved in scaling hydrogen projects across APAC. So we have teams in many of the major markets around East Asia and Australia. And in fact, Australia is probably one of the more interesting markets to look at right now in terms of new hydrogen projects coming online on a larger scale. But we also involved in projects in Singapore, in Korea, in Indonesia, in the Philippines. And these have to do with a lot of strategy development, but also feasibility studies, front-end engineering designs, tender support, owner's engineering projects, and transaction advisory. In Hong Kong, we've been especially active on the hydrogen side. So we were, of course, involved with the EMSD project, where we drafted the safety guidelines for EMSD, which eventually became the codes of practice. We also did a regulatory study on the application of changing from the dangerous goods ordinance to the gas safety ordinance for the scope of hydrogen. We were involved with the waste to hydrogen project. So we did this as a feasibility stage study, a concept design mainly. We also worked on a risk assessment for the transport department as one of their hydrogen depots for their recent HFCV bus. And currently, actually, one of the more interesting projects that we're working on is a liquid ammonia and hydrogen import feasibility study for a confidential client in Hong Kong. Now, why do we take interest in hydrogen for buildings in Hong Kong specifically? There's several reasons for this. The main reason is geographical. Hong Kong has a direct access to a hydrogen supply from mainland China and also can benefit from its potential as a trading hub. Now, I'll talk about this in a minute, but of course, we know about, for instance, the Suiso Frontier project in Japan and Australia, which shipped liquid hydrogen from Australia to Japan, and Hong Kong could potentially, in the long run, as what we've been doing in our feasibility studies, benefit from this new supply chain. In terms of policy and regulation, Hong Kong has also been very active, of course, in terms of, for instance, transferring from the DGO to the GSO, still at the consultation stage at this point. And also a very clear advantage that Hong Kong has over major other cities is that in the town gas network, there's already 50% hydrogen by volume, which benefits building owners who are already connected to the town gas network. And piloting off that, there is a pilot project from Town Gas on using a PSA extraction system for this hydrogen extraction. Now, I did mention that Hong Kong could benefit from an overseas supply chain, and this has been already exemplified by many projects across the world. The first major one would have been the Swiss Frontier back in 2022, but there have been projects since then as well. There's been one shipment from Rotterdam to Shenzhen back in 2024. There's also an example of an ammonia import terminal being developed in Korea specifically for power generation, and also major pipeline projects. Now, here the one I have on screen is one in northwestern Africa, but I think a previous speaker has already mentioned major onshore transmission pipelines in mainland China as well. Just to discuss what quickly we did with our study. So the idea is that we took the town gas pilot project and built around it a high-level concept design using this PSA extraction system. We then developed a regulatory review to understand what would be the regulatory applications of this project and what would impact it most directly. And then we looked at, and this is where it gets most interesting for me, is what would be the potential in terms of decarbonization in the application for buildings. And as the last stage, we're still a consultancy, we had to look at what clients, what stakeholders would be interested in using this kind of system and who would benefit the most. Now, we've talked about the PSA project several times, but a very quick walkthrough. There's a PSA tower in blue here that separates the town gas into residual gas and hydrogen. One flow, the hydrogen stream, goes to a buffer tank, which gets then injected into a stationary fuel cell, whereas the residual gas gets re-injected into the town gas network after compression. In terms of commercial products, there are a lot of off-the-shelf products that you can already use for this kind of application in Hong Kong. They're not actually type approved to be used yet, but they could be. There are some large projects like the Refire manufacturer, who's very interesting. They can manufacture fuel cells up to 3 megawatts in capacity. And then beyond that, there's also smaller scale ones like Ballard, Honda, Toyota. But for this application specifically, what we're looking at is smaller scale fuel cells around the 50 kilowatt range, which is kind of consistent with building energy demand in Hong Kong. And also because it features a built-in inverter, which is very important in this case because we want a fully packaged system, which is easily a plug-and-play system that can be installed by an operator. So I mentioned that we used the town gas system as our benchmark for this concept design, and what we did is a rough sizing based on the E4 fuel cell, the 50 kilowatt system specifically. Now we found that using the town gas specifications, what we can use is just instead of 1, 2 PSA towers, a hydrogen compressor, and instead of 1 residual gas compressor, 3 residual gas compressors. It's pretty much exactly the same piece of equipment. We're only switching out the fuel cell for this application. And the whole concept actually fits within less than 100 square meters spacing, which is interesting because that also includes the separation distances that are required by certain codes like NFPA 2. We could also look at other supply strategies besides the PSA system, but we've looked at several. So there's bottle supply. We could, for instance, buy bottles from Lindy. Why not? But there's a problem here, which is that we would have to replace those bottles so frequently, it would make the application unfruitful in terms of decarbonizing a long-term power supply. We could also use tube trailer supplies, but the logistics of bringing tube trailers into buildings in a dense urban environment like Hong Kong would be impractical. We could also look at direct pipeline supply, but when there is a town gas network to use, why use that why use such a high capex intensive process to deliver hydrogen to buildings? A quick regulatory rundown as well on what this system implies. Currently, it's covered by the DGO, so under FSD, which implies requirements like regular inspections, approval by the Fire Services Department's director, of course. And right now, we have a consultation being run by the EMSD on transferring the state of hydrogen to the GSO, the Gas Safety Ordinance, in the same way that, for instance, town gas is regulated by the Gas Safety Ordinance. And this would introduce new requirements, mainly that EMSD would have the power to introduce new codes of practice, which would regulate and provide standards for how hydrogen is used in stationary fuel cells. It could also introduce new requirements like a QRA requirement, inspections by competent persons every 12 months, or personnel training requirements for building operators. Now, there's no codes of practice actually right now available in Hong Kong for stationary fuel cells, but if our work on the safety guidelines that led to the COPs for the fuel cell vehicles and fuel cell vehicle stations are anything to teach us, that we know that NFPA 2 will likely be the most referenced standard for future COPs. And the implication of this is that mainly we want to avoid the qualification of a bulk storage system. By bulk storage, I mean that any storage that is above 140 normal cubic meters in storage capacity qualifies as a bulk storage and would therefore actually result in new requirements like, for instance, very large separation distances from adjacent buildings or other dangerous goods. So we want to avoid that at all costs, and that's why a PSA system makes so much sense, is that there is no actual on-site storage, only a few buffer tanks, which are well below this storage capacity. Now, we looked at the decarbonization potential of this system, and to do this, I'm just presenting this very basic high-level schematic. There is essentially a power output, which is a 50 kilowatt system. There is a power supply to the compressors and also the pressure swing absorber. And there's also well-to-gate emissions associated with the town gas supply for this project. And on the right, we have a bar chart which just summarizes essentially what would be the GHG emissions per kilowatt hour from this system. Now, if I compare this to, for instance, the use of electricity from the CLP network, what we see here is that there is actually no direct benefit in terms of decarbonization. You might as well use electricity directly. Now, there's a caveat to this, and I'll come to that in a minute. But if your building is connected to the Hong Kong electric system, there's a huge potential for decarbonization. You could reduce your associated well-to-gate emissions by about 35%. And this is based on 2023 data, by the way. And we wanted to understand what that would look like in the future. So to do that, we went through the different sustainability strategies for different utilities, and we plotted them up until 2050 when they decide to achieve net neutrality. Now, we plotted this linearly here, but in practice, we have to understand that, for instance, CLP's emissions would not drop linearly. Instead, they would drop in sort of a stepwise fashion whenever a new facility comes online. When, for instance, HK decides to replace one of their coal-fired stations by a CCGT, there will be a drop in emissions. So this is just purely for forecasting and is not really representative of actual reality. So this is the HK-connected building scenario that we looked at. So in 2023, we see there's a 35% reduction in emissions for a building that uses this system as opposed to HK electricity, but the benefit actually reduces over time because HK has such a drive for reducing their own emissions. So really what happens is by 2035, the emissions benefit from this PSA networked system for a building is actually neutral compared to just using electricity sourced from HKE. For CLP, the picture is a bit more mixed. It starts out pretty much neutral and continues pretty much neutral up until 2050. And that, the rough conclusion that you can draw is that there's no direct decarbonization potential if you are a building connected to the CLP network. But I'd just like to remind people that this is based on linear forecasting. And the idea that we are pitching to building operators and building developers is that we want to decouple emissions from the main utilities, from CLP and HK. So potentially, there is actually still a decarbonization benefit if CLP does not follow through with their exact targets or follows those targets in a more stepwise fashion instead of the linear fashion that we have here. For the fun of it, we decided to also compare what it would look like if we replaced, for instance, a hot water boiler that's using town gas for for producing hot water. And what we found that you're actually better off just burning town gas rather than using this system and changing it to an electric boiler. Now, we looked at also different buildings that might be interested in this kind of system. And there's quite a wide range. We looked at the EMSD energy usage index for all these types of buildings in Hong Kong. And what we find are that buildings that come up to the top of our ranking are really spaces that have a lot of space availability, low energy use, They are directly owned by the occupier, which makes a big difference in terms of who benefits from the system as a form of carbon accounting. There's also synergies with other applications, and this is where it becomes very interesting to talk about hydrogen in transport, hydrogen as a backup fuel, like backup genset system. And then at the bottom of our scale, there comes the buildings that have limited space availability and high energy use. So think, for instance, offices, think about residential buildings. System ownership is more fragmented, so multi-tenanted properties are very difficult for this kind of system. And as a result, there's a limited benefit to the occupiers themselves. And so what we found here is that the buildings that are most relevant to this kind of study are firstly campuses. And I can't remember who was the speaker that mentioned that some universities might be considering using hydrogen-powered vehicles for their campus. Now, this is exactly the kind of application where you have synergies with a PSA-fueled system. There's also the airport, and the airport is interesting because they already have a waste-to-hydrogen project going on right now, and that is to power their ground fleet. So their roadside vehicles, their airside vehicles, and so these could benefit from a source of decarbonized hydrogen. And on top of that, the airport, of course, has a huge amount of space. Now, the only issue here is that we would probably have to do a risk assessment in terms of how close we'd be to air traffic. There are data centers as well, but data centers do have the issue that they have very, very high energy intensity. And so really the decarbonization net impact as a proportion of the energy demand of these buildings is pretty minimal. There could be a side kind of a synergy with backup systems, backup power systems, but these data centers already typically have very, very large diesel tanks on site with a diesel genset. And so to achieve the same amount of energy storage with hydrogen would require a very large bulk storage, although we didn't look at this in detail at this stage. But really, I think the golden boy for this kind of strategy and the most interesting building type that could be benefiting from these kind of PSA systems is warehouses and depots. They are typically the ones that have the most space, either on their rooftop or at ground level. They have very low energy usage and intensity, especially if they're not refrigerated type warehouses. And they can synergize very well with ground vehicle fleets. So by that I mean, for instance, forklifts or tug vehicles, which could also benefit from a hydrogen, decarbonized hydrogen supply. Now, if I had to leave you with 4 key takeaways for this one, the first one is that Hong Kong is very well placed to hydrogen and should harness this potential as a center of a hydrogen supply chain globally. There are commercial solutions. They're just not type approved currently, but they can be imported. There are many, many products on the market right now which can be pretty much readily adapted off the shelf for these hydrogen applications. Decarbonization is more of a mixed picture when it comes to building use, but it should be really examined on a case-by-case basis because there is potential, especially for buildings like warehouses or campuses or airports. And yes, the key stakeholders are those with a relatively large amount of space, those that have low energy intensity, and that can synergize with other services that are provided for hydrogen systems on site. That's pretty much it for me. Thank you very much. I hope that's under 20 minutes.
Thank you, Jeremy, to give us a fruitful talk to